Hi, everybody. We're going to do a PSAT section. This is from a real PSAT back in the day. I think it was 2021, but I will put it in the description so you know exactly which section I'm talking about. This is section 3, the non-calculator for that particular PSAT. And I'm going to move through them fairly quickly. I would work this out. I'd divide by 4 and divide by 4. That's called the common factor. That's going to leave me with 3 and 2, and the x cubed and the x squared goes into x cubed x times, and we're looking at 3x over 2, which is b, and we're done. The first few questions should only take you a few seconds. If you're doing them long, you're doing them wrong. This is a solution to the system of a parabola and a line. This is one of the solutions, so it satisfies both equations. C, and we're moving on. Number 3, this is the equation of a ball after t seconds. Now this is in feet. Now this is the effect of gravity in feet per second squared. This is the velocity that it was moving upward at. So you probably threw it up from 3 feet off the ground. So it's 0 seconds, it's 3 feet off the ground. This is the time that's passing, and it says, what is the meaning of this? Well, the h of 2, and it tells you what h of t means. It's the ball's height in feet. So the ball's height in feet is 11 feet after 2 seconds. So this is C. And I kind of over-explained that one, but there you go. And I forgot to check. I forgot to start my timer. Dang it. Okay. Which expression is equivalent? You have to distribute the negative. There are parentheses around this. It acts like a -1 in front of this, these parentheses. So these are both negative. So I'm going to subtract. I got to take my glasses off, to 2x to the 5th. And I'm also going to subtract the 3x to the 4th. And you have to add or subtract like terms. So this is going to give me 2x to the 5th. And this one is going to be 2x to the 4th, which is B. And we're moving on. Okay, there's the first 4. Hopefully you were able to do those pretty easily. Okay, this is actually true that for every 500 feet of elevation above sea level, the boiling point decreases by 1 degree. So we know that the boiling point is 212. And it's going to decrease 1 degree for every 500 feet. This is your slope, your rate of change. It's changing 1 degree for every 500 feet multiplied by the altitude, where that's x. This is x altitude or elevation. So we're looking at -1 over 500. This is every foot loses this much of a degree, and it's A, and we're moving on. Hopefully that one makes sense to you. Now this is number of goats and number of horses in a 10-acre farm. Well, based on this model, how many acres of land are needed for each horse? So what you need to understand is that this is one of the intercepts, and it represents that you can have 5 horses in 10 acres. If there are no goats. And that means that each horse requires 2 acres. 1 horse per every 2 acres. If you did the same thing with the goats, you would just put the 60 goats in 10 acres. So each goat would require 1/6 of an acre. This is 2, and we're done. I like these a lot. Which of the following ordered pairs? Now, some people are going to graph this situation. It happens to look like this. It's actually a dotted line, and we want y to be less than. It's this inequality right here that you're looking at. This is a dashed line because it can't be on the line. But the easy way to do this is to put in the x's and y's into your inequality and see if it's true. This is x comma y. So 3 is less than 0 minus 4. Is this true? Because I put the y in for y, and the y is 3, and the x is 0. And is this true? Of course, negative 4 is not greater than 3. That's not true. 3, 0. Again, I'm going to put the 3 is the x this time, and the y is the 0. So is 0 3 minus 4? Is negative 1 greater than 0? And that's not true either. And 0, 6, let's see. 0 is the x and 6 is the y. So 6 is less than 0 minus 4. And of course, this is not true. There is only one situation left. That's 6, 0. Let's see if this is true. It says 6 is the x and 0 is the y. Is this true? And it absolutely is. 6 minus 4 is 2. And the last one I checked, of course, is the one that's right. But if you look on your graph, 1, 2, 3, 4, 5, 6, this point is the point 6, 0. And you can see that it's included in your graph. All right. This is a right triangle problem. And one of the issues is that you have to get the angle correct. Angle P is 90 degrees, and we're looking at PQR, so I'm just going to guess. I don't know what it looks like, so I kind of draw some generic right triangle. P is 90 degrees, and then the Q and R, who knows? I'll put the Q and the R. It really doesn't matter if you get it to scale or not. It says the length of side PQ is 70. This is 70. And the measure of angle P is 90 degrees, and angle R is 38 degrees. All right. You should recognize that if we want QR, this is the question mark, this is the X or the Y or whatever you want to call it, you're going to set up a ratio. And you can look over here and you can see it's going to be sine. Well, you should know that because this is opposite and hypotenuse. And so the sine of 38 degrees is equal to the opposite over the hypotenuse. And this is one of those weird situations. I can't just multiply by 70 on both sides because the x is in the denominator. The trick for solving this is you multiply by x on both sides, and the x cancels out, and then you end up dividing by the sine of 38. Some people are just going to guess and maybe guess correctly, but I doubt it. There's my answer. X is equal to 70 divided by sine 38. And there it is. And it is B. And we're moving on. We're doing for time 6. Not doing too well. I got to move along a little faster here. Sorry about that. Here we go. Here's our question. Some of the values of x and the corresponding f of x, this is x and y, of course. If there is a relationship, they want to know which one of these equations makes this true. Well, notice I've got two nice even points here that I can find the slope for. Remember, the slope is the change in y over the change in x. That is y2 minus y1, that's 1. X2 minus x1, that's 6. 1/6 is my slope. I already know that this is out and this is out, so it has to be one of these two. And you can use any point you want to see which one is true. So I'm just going to use the very first point, 2, 1. I'm going to put 1/6 times 2 plus 5/6 and see if I get the correct y value, which was 1. Well, this is 2/6 plus 5/6, which is 7/6. That is not 1. That is out. It has to be D. And let's go ahead and put it in just to show you. 1/6 times 2 plus 2/3. Well, that's 4/6. 2/3 is 4 over 6. You have to have a common denominator. 2/6 plus 4/6 is 6/6, which is 1. And we know for sure that it's D, and we're moving on. When I first saw this question, I thought that it was asking about the equation itself. And so I looked at it. This has a -2 slope. Notice it's going down 2 for every one that goes over. This slope is -2 for this line right here, and it's going through 1. So the equation of this line is negative 2x plus 1, which they definitely could have put on the answers, and I probably would have gotten it wrong. But what they asked for was which of the following has to be perpendicular? Well, you have to know how perpendicular slopes work. A slope of negative 2 over 1 is perpendicular, and I'll put it in red. The perpendicular slope is the negative reciprocal. You have to change its sign and turn it over. That is 1 over 2. The negative reciprocal of negative 2 over 1 is 1/2. Let's see if that's actually true. Put a 1, go up 1, and over 2, and what you're going to see is that this is a perfect perpendicular right here. And of course, this is the slope we're looking for, and it is listed right there, and that's A. We're moving on. Number 11. What is the y-intercept of the graph y equals x minus 4 squared plus 3 in the xy plane? A very, very easy problem if you understand y-intercept. Remember, the y-intercept is where x is 0, and we're looking for a value. So all you have to do is substitute the 0 into your equation. So y is equal to 0 minus 4 squared plus 3. In a way, it's kind of good that you don't have to have a calculator. Some people would put negative 4 squared in their calculator and get negative 16. This is actually negative 4 squared, which is 16, plus 3, which is 19. 0, 19 is my y-intercept, and that's D. And this is a parabola, centered at 4, 3 is its vertex. And that's in vertex form. Anyway, moving on. Which of the linear functions, there we go, sorry. For the given function f, what is the minimum value of f of x? Well, this is a parabola, and if you don't know any better, this happens to be x plus 2 quantity squared, which means that this parabola looks like this. And what is the minimum value of f of x? Well, it goes through 0 right here. You have to kind of know what this value looks like. The f of x is 0 when x is negative 2. So when x is negative 2, y is 0, which is the minimum value of the function. I actually got this wrong before because I was thinking of in terms of 0, 4 being one of the points, and it actually is. It's right here. This is the point 0, 4, but that is not the minimum. Messed it up. Be careful. Easy to make a mistake. Which linear equation has exactly one solution? Well, if I add y to both sides, I get 2y equals 5, and I get one solution. In this one, if I subtract y from both sides, I get 0 equals negative 5, which has no solutions. If I solve this one, I get 0 equals 5, which has no solutions. And if I solve this one, if I subtract y from both sides, I get 5 equals 5, which is all solutions. In fact, this is an infinite number of y's. Y can be anything, and this will be true. So one solution is A. If they had said a solution, it would be A or D, but we want exactly one solution. All right, one final question, and it asks us to find the graph of y equals this funky thing, 4 minus 2 times 0.52x to the x power. This is a fractional exponential equation. And what ends up happening is it ends up going down like this. But this negative 2 turns it over, which means that it's going to end up looking more like this. And the 4 means that it's going to go through 0, 4. Now, I'm going to look for that 0, 4, because if, actually it's not. I'm sorry, my bad. If x is 0, it's not going to make this 0. It's actually going to make this 1 times negative 2. So if x is 0, anything to the 0 power is 1, and I get 4 minus 2, which goes through 2, actually. This is the 1, this is the 2. Little hard to see, but I should have been more careful there. This is what my equation looks like, but you don't actually have to solve any of that unless you just put in the 0, and you know that anything to the 0 power, 1/2, or anything else is 1, and then it gets multiplied by this, and so 0, 2 is one of my points. I'm going to look for 0, 2, and of course I'm looking for this form, but look at this. This does not go through 0, 2. This one goes through 0, 2, but it's going the wrong direction. This one goes through 0, 2, and it looks like it's going in the right direction, so it looks like it's probably C. This one is not going through 0, 2. And I know that this one is wrong because of that negative in front of my exponential. That negative in front of your exponential is a reflection across the x-axis. I could also do another point. This says that 4 gives me 0. Well, if I put a 4 in here, I'm going to get a little tiny fraction because 0.5 to the 4th power is a very small fraction. It's 1 over 32, 1 over 16. And multiplied by 2, it's going to give me 3 1/8. And there, this is the answer, by the way. So this one is out because it's going the wrong direction. Kind of a hard problem. Last one. This one is a circle, and it's not in standard form. Normally, we like to have the centered form. And it looks like this: x squared minus 6x plus some number plus y squared minus 4y plus some number equals 0. What you end up with is x something squared plus y and something squared is equal to some radius squared. This is the standard form for a circle. And if you don't know how to complete the square, we're just looking for the number that goes in here that makes this true. A minus 3 makes this a negative 6x in the middle. So this is going to be plus 9 right there. It's called completing the square. If you want to look it up, you should know completing the square even from Algebra 1. But if you don't, that's called completing the square. And if I add 9 to this side of my equation, I have to add 9 to that side. And this one, this is y minus 2. And when we square it, we get a positive 4. So I have to add 4. And now I get the square root. What happened? Did I? Oh, 8y. Dang it. Can't read today. Sorry, guys. This is an 8. This is 4. I was wondering why that didn't work out. This is 16. My bad. I'm sorry. Can't see very well. It looked like a 4 before. Now I can see it on there. This is minus 4 squared, because if I square it, I get this polynomial. This is called a perfect square trinomial. And again, this is completing the square, so I had to add the 16. When I add these two together, I get 25. And my 25 happens to be r squared. And r is 5. And that's your last one. Hopefully you got it. I know some of them, this one in particular was very difficult. I know that knowing your exponentials and how they're related to one another. But if you did some graphing theory, you should be okay. Hopefully you got it. I'll see you back again. Bye.